In this presentation on relations and functions, we are going to talk about some problems based upon types of functions. Now the first question we have is, show that the function f defined from R to R, set of real numbers to real number, it is defined like fx is equal to x square, is neither 1 1 nor 1 2. So one method we have, it is using the graphical method. We are not using that method over here. We are going to prove this result algebraically. So to prove that it is not 1 1, we are saying that there are two elements minus 1 and 1 in the domain set such that f of minus 1 if we calculate using the definition of this function, it is minus 1 square, that is equal to 1, and we have f of 1 that is equal to 1. So we can see that there are two elements minus 1 and 1 in the domain that have the same image. It means that f is not a 1 1 function. Next, to prove that it is not onto, we have to show that there is some element in the codomain which has no pre-image. So we are saying that there is an element minus 1 in the codomain which has no pre-image, because there is no element x in the domain for which x square is equal to minus 1. We are saying there is no element in R whose image is minus 1. That is, x square cannot be equal to minus 1 for any x belongs to R. We are talking about the condition that x square, it cannot be equal to minus 1 for any x belongs to R. So we are saying that this function f is not an onto function. Now the next question we have is, show that the function f defined from R to R, and it is defined like fx is equal to mod x, is neither 1 1 nor onto. So again, we are saying there are two elements we are talking about. It is, if we calculate the value of f of minus 1 is the element of the domain, and the value of the function that is equal to mod of minus 1, that is equal to 1, and f of 1 if we calculate, then we have f of 1 is equal to 1. So we have shown over here that there are two elements minus 1 and 1 whose image is 1. It means two different elements of the domain have the same image. So this function f is not a 1 1 function. Next is, to prove that it is not onto, we have to show that there is an element of the domain for which there is no of the codomain for which there is no pre-image. So if we consider the element minus 1 from the codomain, if we are considering the element minus 1 from the codomain, we are saying that there is no real number x whose modulus is minus 1. It means that minus 1 belonging to R has no pre-image in R. So what we obtain is that f is not an onto function. So what we can see from these examples is that if we have to prove that the function is not 1 1 or function is not onto, then we can give a particular example to disprove these kind of statements. Next is, for any real number x, we define this is the greatest integer less than equal to x. We have to prove that the greatest integer function, it is defined from R to R. The domain is R and codomain is R, and we have to prove that fx is equal to greatest integer of x, it is neither 1 1 nor onto. So again, we have to give some examples over here, counter examples we are saying. So first of all, we are considering the value corresponding to the number. We are talking about the greatest integer of 1.2. From the definition of greatest integer function, we know that this value is equal to 1. And the greatest integer of 1.3 is also 1. So we are saying that f of 1.2 and f of 1.3, both these values, these are equal to 1. So what we obtain is that there are two different real numbers, that is there are two different elements from the domain that have the same image. So what we get is that f is not a 1-1 function. Next is we have to prove that it is not onto. We have to give an example. So we consider an element from the codomain, and suppose that element we are considering that is equal to 1.1. So we want to find a real number. We are saying we want to find a real number such that greatest integer of that real number is equal to 1.1, and we can clearly see that there is no real number x such that f of x, that is greatest integer of x, is equal to 1.1. It means that there is an element in the codomain which has no preimage. So what we get is that f is an into function, it is not an onto function. Now next we have is let R naught be the set of all non-zero real numbers. R naught is this set, and we have to show that the function defined from R naught to R naught, it is fx is equal to 1 by x. This function is 1 onto function. Now to prove 1 we are saying we consider that f of x1 is equal to f of x2. By the definition of this function, we have fx is equal to 1 by x. By the definition of this function, we are saying that 1 by x1 is equal to 1 by x2, and this implies us that x1 is equal to x2. So what we have proved is that there is no element of the codomain which has two pre-images. So we are saying that f is a 1-1 function. Next we have to prove that it is onto. So we are considering y is equal to 1 by x. So if we calculate the value of x over here, we obtain x is equal to 1 by y. We have to prove that every element of the codomain has a pre-image. So we have considered the element 1 by x. We are saying suppose it is equal to y, and corresponding to it we have calculated the value of x as 1 by y. So we are saying that if y is a non-zero real number, then clearly x is equal to 1 by y is a non-zero real number, such that we have f of 1 by y that is equal to y. So what we have proved from this thing, what this thing means is that for each y that is a non-zero real number, it has its pre-image as a non-zero real number. It means every element of the codomain has a pre-image, and this proves that the function f is an onto function. Next we have is show that the function f defined from R to R, it is from real numbers to real number, and fx is equal to x cube is 1 and onto. So again, to prove that it is 1 we are going to consider that f of x1 is equal to f of x2. By using the definition of this function, this implies us that x1 cube is equal to x2 cube. Now when we solve this equation, this implies us that x1 cube minus x2 cube is equal to 0. Using the formula for whole cube, we obtain this is x1 minus x2 into x1 square plus x1 x2 plus x2 square, and this value is equal to 0. Now look at this term over here. We are saying it is x1 square, x1, x2 and x2 square. If we complete the square corresponding to both these terms, we have x1 square, we have x2 square, we complete the squares corresponding to both these terms, we obtain, we are having this first term, it is x1 minus x2. This second term we are talking over here, we can write it in the form, we are saying we have x1 square plus x1 x2, and we are adding to it another term. We are having this is x1 over here, the half of this multiplied by 2. So we get it is x2 by 2 square we are adding, and x2 by 2 square we are subtracting, and we are having x2 square over here. So on solving this value, we obtain the answer in this form. The first whole cube that we obtain, whole square we obtain, it is x1 plus x2 by 2 whole square, and the remaining term we are left with is plus 3 by 4 x2 square. So these are the terms we obtain, and this value is equal to 0. And clearly we can see this term, it is square, it is greater than equal to 0. This term, it is square, it is greater than equal to 0. And we are saying that we have two cases over here. Either this value is equal to 0 or this whole value is equal to 0. So in the first case, we are talking over here, it is, we are saying this implies us x1 minus x2 is equal to 0, which implies us x1 is equal to x2. And in the second case, if this term is equal to 0, we are saying both these terms, x1 plus x2 by 2 and 3 by 4 x2, both these terms should be 0. This implies us that this value is 0. So what we get from this is that x1 is equal to x2 is equal to 0. I am again repeating this step. We are saying we have these two terms are over there. We are having these two terms. We are saying either this term is equal to 0 or this term is equal to 0. If we equate x1 minus x2 is equal to 0, we get x1 is equal to x2. And if we equate this term is equal to 0, we are saying this will be 0 only when x1 is equal to x2 is equal to 0. So in both the cases, we have obtained that x1 is equal to x2. So we are saying that function f is a 1-1 function. Next, to prove that it is onto, we are saying let y belongs to R. There is an element in the codomain, and we suppose that y is equal to x cube. We have to prove that this y has a pre-image in R. So we can write from this that x is equal to y raised to the power 1 by 3, and this will also belong to R because it is cube over there. So we can write x is equal to y raised to the power 1 by 3. So what we have proof over here, what we can see from this is that for every y in the codomain R, there exists y raised to the power 1 by 3, that is cube root of y. This number, this will also be a real number, and it will satisfy the property that f of y raised to the power 1 by 3, it will have the value y raised to the power 1 by 3 whole raised to the power 3, that is equal to y. So what we obtain from this is that every element of the codomain, it has a pre-image. So what we get is that f is an onto function. Next, we have to show that the function f defined from R to R, and it is fx is equal to 1 plus x square, is many one and into. So to prove that it is many one, we have to show that there are two elements in the domain that have the same image. So those two elements, we can see that f of minus 1, if we calculate, the answer we get that is equal to 2. And if we calculate the value of f of 1, the answer we get it is 2. So clearly we are saying that there are two elements of the domain that have the same image. So this function, it is a many one function. Next, we have to prove that it is into function. So we have to show that there is an element in the codomain. Codomain means there is a real number for which there is no pre-image. So if we are considering the number minus 1 belongs to R, we are saying we consider the number minus 1 belong to R. So what we will have in this case, we are saying that minus 1, that should be equal to 1 plus x square. We want to find an x belongs to R such that minus 1 is equal to 1 plus x square, and this thing is never possible. We cannot find any real number for which 1 plus x square is minus 1. So we are saying that minus 1 has no pre-image in R. So this function, it is an into function. Next function that is given to us, it is f is defined from R to R, and it is defined like fx is equal to x raised to the power 4, and we have to prove that it is many 1 and into. Now again it is x raised to the power 4. So if we are talking about the number minus 1 and 1 from the domain, we have f of minus 1 that is equal to f of 1 that is equal to 1. So clearly this function f, it is a many 1 function. There are two different elements of the domain that have the same image. And if we consider the number minus 1, a real number minus 1, so this number has no pre-image in R. It means that this function is a into function. Next is show that the function f defined from R to R, and the definition of function is fx is equal to x raised to the power 5 is a 1 1 and onto. So look at the difference over here. When we are talking about x raised to the power 4, it is neither 1 1 nor onto. When we are talking about the function x raised to the power 5, it is both 1 1 and onto. So to prove this result, what we are going to do, we are considering f of x1 is equal to f of x2. This implies us x1 raised to the power 5 is equal to x2 raised to the power 5. And when you solve this, you will get x1 is equal to x2. So what we obtain from this is that the function f is a 1 1 function. And for onto part, we are saying that for each y that is a real number, we have the number y raised to the power 1 by 5 belonging to R, such that f of y raised to the power 1 by 5 is y. So we are saying that f is onto function. We have to show that the function f, it is defined from the set of natural numbers to natural numbers, and it is defined like fx is equal to x square, and we have to show that this function is 1 1 and into. Now it is important to note over here that both domain and codomain, they are natural numbers. So we are talking about, to prove that it is 1 1, we are saying we consider f of a is equal to f of b. So if f of a is equal to f of b, we get a square is equal to b square. Now both a and b, they are the natural numbers. So what we get is that this implies us that a is equal to b. So we are saying that the function f is a 1 1 function. The function f is 1 1 function. Next we have to prove that it is not onto. It means we have to show that there is an element in the codomain which has no pre-image. So if we consider the element 2 in the a natural number 2, we can see that there is no pre-image of this number 2 in the set of natural numbers, because we are saying that 2 is equal to x square. We want to find an x square for which 2 is equal to x square, and there is no natural number x for which 2 is equal to x square. So we are saying that this function f we have over here, it is an into function. Now we look at another example. Suppose we are saying f is a function and it is defined from the set of integers to the set of integers, and it is defined like fx is equal to x square. Now compare these two functions. In this case, the both domain and range, they are set of natural numbers. Over here we are saying domain and codomain, they are set of integers. So we are saying fx is equal to x square. We have to prove that this function, it is many one and into. So to prove that it is many one, we are saying that there are two elements -1 and 1 such that f of -1 that is equal to f of 1 that is equal to 1. So this proves that this function f is a many one function. And to prove that it is into, we are saying that there is an element -1 in z that has no pre-image in z. That is, there is no integer for which x square is equal to -1. So we are saying that this function f is an into function. Next is f is defined from the set of natural numbers to natural numbers, and fx is equal to n cube. We have to prove that it is 1 1 and into. So we are considering f of x1 is equal to f of x2. So this implies us that x1 cube is equal to x2 cube, and this implies us that x1 is equal to x2. So what we get from this is that f is a 1 1 function. So we have proved this part. Next we have to prove that it is into function. So we have to show that there is an element in the codomain which has no preimage. So we consider the element 2 that belongs to the codomain, and we can see that 2 raised to the power 1 by 3, which is not a natural number. So there is no element in the domain which has image 2. So we are saying that this function f is an into function. Next, if we consider the function f from z to z, and the function is defined like fx is equal to x cube. In this case, the domain was natural number, codomain was natural number. Over here, the domain and codomain, they are integers. So we are saying that we have to prove that this is 1 1 and into. Again, to prove the 1 1 part, the proof is similar. We are saying f of x1 is equal to f of x2. This implies us x1 cube is equal to x2 cube, and this implies us x1 is equal to x2. And for the into part, we can give the same proof. We are saying that 2 belongs to z, but 2 raised to the power 1 by 3 does not belong to z. So clearly we have f is an into function. So we have proved that this function, it is 1 1 function but not an onto function. So from these 4 examples, we can see that what the domain and codomain plays the role when we are talking about these kind of functions. And second thing we can note from here is that when we are talking about the function like x square, x raised to the power 4, x raised to the power 6, then the behavior of the functions with or the polynomial functions with even degree differs a lot from the behavior of the functions or the polynomial functions with the odd degree.